G'day guys, I've got a couple of questions on finding inverses of matrices. I've chosen to do 2 by 2 matrices today because if you're in high school, the only dimension of matrix that you're going to have to be able to do by hand are 2 by 2s. So let's go about solving these. First of all, to be able to work out a matrix inverse, or if a matrix is going to have an inverse, the first thing is that it has to be a square matrix. It has to be a 2 by 2, a 3 by 3, a 4 by 4, etc. The second of all, the determinant of a matrix, which is equal to 1 over AB minus CD, has to be non-zero. So I'll go through them again in a second, but basically we have to have a square matrix and the determinant of the matrix cannot be equal to 0. So let's go through how we would work out a inverse of a 2 by 2 matrix. So to start with, if we have a matrix, let's call it matrix M, which looks like this. It's a 2 by 2 and we have A, B, C, D. Now this is probably a relationship that your guys are going to have to memorize. If we have a matrix that looks like that, its inverse, which is usually denoted m to the negative 1, the inverse of matrix M, will be equal to 1 divided by AD, so A times D, minus B times C. And this is our determinant of the matrix, so that cannot be 0, otherwise the whole inverse will be 0. Multiplied by, what we do is we swap the A and D terms, so we're going to have a D up here, and we're going to have an A down here, and we flip the sign on the B and C terms. So this is going to be negative B, negative C. And that is the inverse of a 2 by 2 matrix. So if I'm going to apply this to the matrix A that I have up here, the inverse of A is going to be equal to 1 over AD, so A times D. 5 times 1 is 5, minus 2 times 0, which is 0. So we flip the A and D terms. We have a 1 up here, we have a 5 down here, and we flip the sign on the B and C terms. So this is going to be still 0. You can't have a negative 0, and this is going to be negative 2. Cool. So simplifying that a little bit, this is 1/5. We can multiply that into the matrix. So we have 1/5 times 1, which is just 1 over 5. We have 1 over 5 times 0, which is still 0. We have negative 2 over 5. And we have 5 over 5, which is just 1. So there is our inverse of matrix A. Now, I've chosen to do this matrix B here because it's got our variables in it, but it makes absolutely no difference to the method to which we go about working it out. So let's try the inverse of matrix B. And this is going to be equal to, again, we find the determinant, 1 over AD, x times 1, which is just x, minus y times 0, which is just 0. And we're going to multiply this by, we flip the A and D terms, so we're going to have 1 here. We're going to have an x down here, and we flip the sign on our B and C terms. So we have negative y, we have negative 0, which is still 0. Cool. Now we can simplify this because we've just got 1 on x as our determinant, and we're going to have, so let's just write the inverse of b is equal to, well, it's going to be 1 on x, because we times 1 on x by 1. Then we have negative y on x, because we're timesing that by that. We still have 0. And we have x on x, which is just 1. And that, guys, is the inverse of matrix B. So you can see that if you learn how this particular formula here works, and you're able to commit this to memory, it doesn't matter what 2 by 2 matrix you're given, you can apply this formula. So we were given one with just regular numbers, and we were given ones with unknowns, and we were still able to get the inverse of both matrices. What is good about finding the inverse of matrices is that if we can do a lot of matrix algebra and we use the inverse of matrices to cancel out, so to speak, matrices when we want to take a matrix to the other side when we're doing algebraic expressions using matrices, because a matrix multiplied by its inverse is equal to the identity matrix. And this little relationship here will come in very handy later on in your mathematical journeys, guys. But until then, keep practicing this. Make sure this is committed to memory, and you shouldn't have any problems doing these matrix problems. You shouldn't have any problems doing these matrix problems. You shouldn't have any problems solving these matrix questions. But until next time, guys, if this video was helpful, give it a like. Subscribe to my channel. I put out new videos all the time on maths and other bits and pieces. But keep practicing and keep enjoying your maths.